Okay, so we have a few questions we want to look at. The whole goal to this is to use trig identities to simplify. That's the whole goal for these. Here's a problem here from the homework set. The first one, number 29, sine of phi, that's the Greek letter phi, times cosecant of phi minus sine of phi. And one of the biggest challenges to identities is understanding where to even start. What in the heck do we want to do? I don't even know where to start with this stuff. So one of the general guidelines, one of the general rules is to look at what you have to start with. You have a product here. You have this thing times this thing. Anytime you have a product, anytime, one of the things you would like to do is to turn each of those expressions into fractions in such a way that something will cancel out. Now that's just a general statement. That doesn't help a whole lot if you don't know what fraction to turn it into. So if we look at this, go back to your reciprocal identities. Right? Sine of phi as a fraction is the same thing as 1 over cosecant of phi. Again, if you don't believe that, go to page 354 in our textbook and look at it. That's what that is. Now, is this going to be helpful? I don't know yet, but I know that if I turn that into a fraction, maybe I can turn this thing into a fraction and multiply it together and something cancel out. Well, the challenge with this is that cosecant of phi minus sine of phi doesn't turn into any kind of fraction. And so some of y'all may say, well, okay, well, cosecant is 1 over sine, and sine is 1 over cosecant. And that is true, but you're subtracting the two. So then what do you do with the fact that you're subtracting? In other words, in the end, if I try to multiply this times this, am I going to get something simpler? I'm not. If I multiply this times this, then what I have to do is multiply this times this, algebraically, and then this times this. And I'm going to end up with a longer mess than I want to. So that right there should tell you that that strategy right there will end up in a dead end. And again, some of you may be going, well, how'd you even know to do that? Well, like I said, if I turn these into fractions and if I multiply, just understanding something like multiplication, I'd have to multiply this expression times both of these individually. That's not going to cancel anything out. That's going to make things even bigger. We don't want that to happen. Our goal is to simplify. So, we're back to square one in something like this. So, what do we do now? Well, this is where, honestly, you just do some trial and error. I noticed that I am multiplying this times this, and this middle part is cosecant minus sine. So, what if I just distributed sine across that? In other words, what if I said, what is sine times phi, sine of phi times cosecant of phi minus sine of phi times sine of phi. In other words, I distributed this sine across both of those. Okay, you guys see that part? Okay, what if I did? What would that turn out to be? Well, sine of phi times cosecant of phi is just sine of phi times cosecant of phi. Will it simplify? Yeah, it will. We'll talk about that in a second. What is sine of phi times sine of phi? It is sine squared of phi. Let me rewrite that because my board is not being nice. And so again, you guys may be looking at this going, well, I don't know what to do with this. Well, first thing, we've multiplied, haven't we? So the next thing I would like to see is this part right here, which I'm underlining in red. Well, it's a product. And so we've always said, if you have a product, can we turn it into fractions in such a way that things cancel out? In other words, I could keep sine of phi just like it is and not do anything with it. Or I could make sine of phi into 1 over cosecant of phi. I could do that. Or I could take cosecant of phi and just leave it like it is. Or I could turn cosecant of phi into 1 over sine of phi. And the reason I'm writing all these down is that the end result is I want to multiply this thing times this thing and hopefully simplify it and cancel things out. Well, of the red and the green you see up there, if I pick any two that I want to, one red and one green, which one can I pick in such a way that something will cancel out? Well, I notice up front, I can take this sine of phi, and this 1 over sine of phi. And if I multiply them together, if I multiply that as sine of phi times 1 over sine of phi, that's a phi, by the way, right? Then what I have is sine of phi, that's this sine times this 1, divided by sine of phi, which turns out to be 1. So here's what I know. Sine of phi times cosecant of phi is equal to 1. Now, you may want to stop the video right here and write this down because I'm about to erase all the green stuff just to unclutter this. Right? So what I have then, I've multiplied the blue sine of phi times the blue cosecant of phi. I've changed them into identities, and the result is 1 right there. So, again, I just erased all the stuff, but what we found out was that this sine of phi times cosecant of phi is the same thing as 1. So we just substitute 1 minus sine squared of phi. So what we've done so far is when we multiply sine of phi times cosecant of phi minus sine of phi, it results in 1 minus sine squared of phi. That's what it results in. Now the question is, can we go any farther with that? Which is always the goal of identities. We need to work it down until we have one simple expression. And a lot of students have trouble with that because they don't know where to stop. How do I know when I can go farther? Well, you just have to practice this stuff. That's the correct answer to that. All right, 1 minus sine squared of phi. Notice that you have a 1 and a squared involved. And so another strategy with this is anytime you have 1s and squares, or really anytime you have squares, but anytime you specifically have 1s and squares, look to your Pythagorean identities and see if that can further simplify things. So now the next question is there a Pythagorean identity that combines 1 and sine squared of phi? There is. That identity looks like this. Sine of phi, sine squared of phi, plus cosine squared of phi is equal to 1. Now, if you look at your textbook, they use the letter u instead of phi, but that part's irrelevant. And sine squared plus cosine squared is equal to 1. Now, how can we get this expression right here to manipulate in such a way that we have 1 minus sine squared together? How can we do that? Well, this is just where we now use some algebra. How can I get 1 and sine squared together? I can subtract sine. Let me remove this circle here. Let's take a second out just to erase that. Don't clutter the board anymore. What can I do here? Well, if I subtract sine squared of phi from both sides, and here's what I'm left with. Cosine squared of phi is equal to 1 minus sine squared of phi. I'll just say phi here. Now, if I look at that, then cosine squared of phi is equal to 1 minus sine squared of phi. So that means this. I can take this part right here. That is the same thing as cosine squared of phi. So what I've done is I've taken sine squared, sine of phi, times cosecant of phi minus sine of phi, and I have used identities and multiplication first, and then identities to simplify it, so that this thing actually turns out to be, in simplified form, cosine squared of phi. Okay, so we have a question here. 1 minus sine squared of x divided by cosecant squared of x minus 1. Again, I'm going to amend what I've said earlier in that I said that one of your general strategies was if you have a product, you should try to turn one or both of the expressions into fraction identities, reciprocal identities, in such a way that things cancel out. Okay? But in this case, it also works with quotients. Or not in this case, it also works with quotients. It's the same thing. So, the next question is how do I take 1 minus sine squared of x, cosecant squared of x minus 1, and turn them both into fractions in such a way that things cancel out? Well, we can't turn 1 minus sine squared into a reciprocal identity. We can't do that, nor can we do cosecant squared minus 1. We can't turn them into reciprocal identities or quotient identities. So we fall back on another guideline I gave you, and that guideline was if you have, this isn't being nice, if you have things that have squares, and definitely if you have things that have squares and ones in them, use your Pythagorean identities to hopefully simplify things out. So in the previous problem, we've already discovered 1 minus sine squared of x is the same thing as cosine squared of x. And just as a refresher, we have an identity that says sine squared of x plus cosine squared of x is equal to 1. So if I were to subtract sine of x, sine squared of x, and what I know is that cosine squared of x is 1 minus sine squared of x. And since I have 1 minus sine squared of x in my original problem, this is the same thing as that. So I'm just substituting. That's all I'm doing. Right? So I'm about to erase this, so you may want to stop the video and go through your copy of this down part, because I'm about to erase this. Okay, it's still recording. Now, cosecant squared of x minus 1. Is there a Pythagorean identity that links that together? Do we have a Pythagorean identity that links cosecant squared and 1? As a matter of fact, we do. 1 plus secant squared of x is equal to cosecant squared of x. I'm wrong about that. I'm sorry, I said that wrong. This should be 1 plus cotangent squared of x. Am I right about that in class? 1 plus cotangent squared of x is cosecant squared of x. So now, how can I take this expression in red and get cosecant squared of x minus 1 together in one spot? Well, I can subtract 1 from both sides, algebraically. So I have cotangent squared of x is equal to cosecant squared of x minus 1. So here's what I know then. I know that cosecant squared of x minus 1 is the same thing as cotangent squared of x. And I'm dividing, so I'll just simply draw a line through it like that. So what I have done is I have simply taken 1 minus sine squared of x and turned it into cosine squared of x. And I've taken cosecant squared of x minus 1 and turned it into cotangent squared. Now, have I simplified things? Honestly, not really. I want to be able to simplify things. So again, I'm about to erase a lot of this stuff, so if you want to copy down what I just did, pause the video to do that. Okay, so now the question is what can we do with this? Well, cosine squared of x over cotangent squared of x is a quotient, and can we turn these things into reciprocal identities or multiply it somehow so that things work out? All right, now, the trick is this is knowing this little thing right here. I'm going to take a little side trip. For example, we know that, say, cotangent of x is cosine of x over sine of x. That is our identity. But what you may not know is that if you were to square cotangent, and if you were to square these right here, then cotangent x squared is cotangent squared of x is equal to cosine squared of x over sine squared of x. And the point I'm making is that in your reciprocal identities, you can use squares and triplicates and stuff like that. In your Pythagoreans, they have to stay as squares. They can't change. You can't square root them or anything like that. But your reciprocal and your quotient identities, you can carry the squares over into that. Now here's why I'm doing that, because if you go by the pattern I'm showing you, just simply writing it out, you have a choice of some things. You can keep cosine squared of x like it is, or you can turn it into 1 over secant squared of x. Because cosine is 1 over secant, cosine squared is 1 over secant squared of x. All right, cotangent squared, we'll put that in red. You can keep it like it is, or you can turn cotangent squared into cosine squared of x over sine squared of x, or you can also turn it into 1 over tangent squared of x. And again, you are not required to have to write all these down, but the idea is that we need to pick one blue and one red and divide it out such a way that things cancel out. And remember, when you divide, the denominator gets flipped over and you multiply straight across. So if I look at the combination of things right there, if I was to do that, I want to try to take something in blue and something in red and cancel things out with that. So I'm going to try this. I'm going to keep the cosine squared of x like it is. In other words, I'm going to keep that one there. And then what I'm going to do is I'm going to pull this one up, because I remember, since I'm dividing, I'm going to have to flip this part over. So what I have is cosine squared of x, and again, I'm thinking strategically. This is what I'm saying is I'm turning cotangent of x into cosine squared of x over sine squared of x. But if I want to continue this out, that's like saying cosine squared of x over 1 times, remember the bottom flips over, sine squared of x over cosine squared of x. Like I said, I have to think strategically. Yes, I'm multiplying, but the bottom number I'm multiplying in its reciprocal form. Okay, now I can look at this and I can tell, I know now that cosine squareds are going to cancel out. And so I'm left with sine squared of x over 1, which is the same thing as sine squared of x. So the bottom line is, if I take 1 minus sine squared of x and divide it by cosecant squared of x minus 1, the final simplified result is sine squared of x. So what I've done is I've already started this. The original problem was like this. That was the original problem. That was what it was. We want to simplify this. And so I went ahead and I've already simplified this, or rearranged it, because again, we have a quotient, and the idea behind a quotient is that we turn either the numerator or the denominator or both into reciprocals in such a way that when we divide it out, things cancel out. The problem is that this part right here, 1 minus sine of y, doesn't easily translate into a reciprocal or a fraction to do anything with. Not easily. You know, is there a way to do it? Well, perhaps, but it requires more work than we want to put into it. So the other part of things was, like I told you, another part of the strategy is that when you have squares, look to your Pythagorean identities. I'll try to erase this here. Look to your Pythagorean identities and see if you can simplify things. And we have already seen from the previous set of problems that cosine squared of an angle is the same thing as 1 minus sine squared. We've already seen that from the other problems. So if you forgot how to do that, reference back to the previous two problems, or the previous problem, and then I show you how to do that using sine squared plus cosine squared is equal to 1, working it through. Okay, so that being the case then, I've gotten this far. So what I've done is I've turned cosine squared into 1 minus sine squared, and 1 minus sine of y, I left it like it is. Now, your desire, I say a general desire of a lot of students is to look, well, what I'll do is I'll just divide 1 into 1, and I'll divide negative sine of y into negative sine squared of y, and I got what I need. That does not work algebraically or mathematically in all cases. Now, it just so happens that in this particular case, the end result would look like if you divided them out, but mathematically that's not correct, because you have a fraction in which the numerator divided by the denominator would mean that you would have to divide all of 1 minus sine of y into 1, and all of 1 minus sine of y into 1 minus sine squared of y, and it doesn't work like that, so we're not going to try to do it that way. However, we are going to notice something here. This 1 minus sine squared of y can be re-expressed as 1 minus sine of y times 1 plus sine of y. And the reason we can do that is because, I'll change marker colors here, 1 minus sine squared of y is a difference of squares. In other words, I could re-express this as 1 minus y squared. And hopefully you found out from your previous algebra classes, 1 minus y squared is a difference of squares, and all you do is you take the square root of the first term, which is 1, minus the square root of the second term, which is y, and then multiply it by the square root plus the square root. Okay, so this is just simply a difference of squares. That's why I can take 1 minus sine squared of y, because 1 is a perfect square and sine squared is a perfect square. And since I'm just subtracting the two of those, I have a difference of squares, and that works. All right, so I'm going to erase this, so you may want to stop the video if you want to, and copy that part down, because I'm about to erase this, just to get the clutter out of it. All right, so now if we look at this, now we have this over 1 minus sine of y, and now that we're multiplying, that works, and then we can cancel that out and cancel that out. So our final result is 1 plus sine of y. So if I take cosine squared of y and divide it by 1 minus sine of y, I get 1 plus sine of y. Bam.